Have you ever connected a sensor or switch to a microcontroller, only to find its input reading erratically jumping between high and low when nothing is actively driving it? It is a common puzzle, making you wonder why the pin behaves so unpredictably. Well, the secret to understanding and controlling this behavior lies in tiny but mighty components built right into your microcontroller: internal pull-up and pull-down resistors. These resistors are specifically designed to define a clear, default electrical state for an input pin when no external signal is actively connected, preventing what is known as a floating pin condition. A floating pin is like a boat without an anchor. Its voltage level is undefined and highly susceptible to electrical noise and interference, leading to unreliable readings. This happens because the high input impedance of the microcontroller pin means it draws very little current. Without a defined path to either the high voltage supply or ground, any stray electromagnetic fields can induce a voltage, making the pin appear to randomly switch between digital 0 and digital 1. Internal pull-up resistors connect the pin to the supply voltage, setting a default high state, while pull-down resistors connect it to ground, setting a default low state. This provides a stable, known voltage reference. These resistors are crucial for ensuring the stability and predictability of your digital circuits. For instance, when connecting a simple push button, you might use an internal pull-up resistor. When the button is open, the pin is pulled high by the resistor. When the button is pressed, it connects the pin directly to ground, overriding the resistor and bringing the pin low. This setup guarantees that the pin always has a defined state, whether the button is pressed or released. A key concept here is the weak nature of these resistors, typically ranging from 20,000 to 100,000 ohms. This higher resistance means they only supply a small amount of current, making it easy for an external signal or component to override their default setting. This flexibility allows them to establish a default state without hindering the actual signal when it arrives. Some advanced microcontrollers also allow you to configure these resistors through software, providing even more control over pin behavior. Ultimately, by understanding and utilizing internal pull-up and pull-down resistors, you gain precise control over your microcontroller's input pins, eliminating erratic behavior and building more robust and reliable embedded systems. They are fundamental tools for any electronics enthusiast looking to design predictable and stable digital interfaces.